Intention of this particular video is to reinforce that particular concept with the help of a practical example. So in this case, we will take off a industrial scenario and try to do the LOPA for the same. So, and I will also provide you the template of conducting LOPA. So if you go through this particular video, you will not only understand what LOPA is, but you have a practical exposure of LOPA also. And you can start doing LOPA in your unit or your area where you are actually working. And this adds on to your experience, right? So let's begin with it. So this is the process, and this particular process actually we have discussed it during the 𝐻𝒂 analysis also, and for the 𝐻𝒂 we considered the same process. So you can correlate how the actually things are done. First there will be 𝐻𝒂, and from the 𝐻𝒂 points, if there is a need for quantification, then we went into LOPA, and from the LOPA we check whether there is any requirement of any seal, or if there is a requirement, what will be the categorization of the seal, right? So this particular process, this is there is a feed flow that is happening, and it is going into a HP separator, right? And HP separator, there is a level switch in the HP separator. So if the level goes low, this particular on-off valve gets closed, and there is another level switch or level transmitter rather, which is connected to a control valve which controls the level of this particular HP separator, and the output goes to a liquid drain or another drum where the vapor goes out, and from the bottom the liquid drains out. Okay, now we conducted 𝐻𝒂 for this particular case, and this is the 𝐻𝒂 report, as you can see. So there may be different consequences, like or different deviation that may happen there, like no flow or more flow. In this case, we will consider the more flow situation. So if the flow, how the more flow can happen, so this may happen when this LP001 may be stuck open, it is not getting closed, or the manual bypass valve across this liquid control valve is accidentally open or open by mistake. So in this case of the more flow, what will happen? Level will decrease in this HP separator, resulting in gas breakthrough. Okay, so this is a undesirable situation. So to avoid this, what protection or safeguard is provided? Number one, there is a alarm that is provided on the level switch, and also the level switch trips the XB. So this is another protection or another interlock that has been provided. Another recommendation can be that we can provide limit switch on the manual bypass valve to check whether this bypass valve is open or not. So this is the 𝐻𝒂 report. So from this 𝐻𝒂 report, we are not sure about the probability of occurring this event, and whether we really need a safety instrumented system, or even if we need, what should be the availability target for the safety instrumented system. So for example, in this case, there is a safety instrumented system consisting of this initiator, which is a level switch, and there will be a logic solver, which is a PLC, and this final element or on-off valve. But can we choose a ordinary level switch in this purpose, which is having a very high failure rate? And also on-off valve, can we choose a ordinary on-off valve with a high failure rate, or we need to choose very sophisticated one? So all these questions can be answered if we can do a quantitative risk analysis, and this quantitative risk analysis is possible with the help of the LOPA. So this is the point where the 𝐻𝒂 ends, or with the 𝐻𝒂 we cannot conclude conclusively, and we need to move further towards LOPA. So as we know that this is the flow chart of the LOPA, so first we need to identify the design intent and scenario, and then there will be two parts. One is going to assess the overall demand frequency. So this part, how we will do. So again, this is the chart or the template of the LOPA. As you can see, it consists of the impact or event description, its severity level, initiating cause, initiating event likelihood, and then IPL, and what is the protection level of the IPL, and then you get the overall PMD, which is the same as your resultant demand frequency. This is the thing that we want, right? So again, we go one by one. So what is the impact event frequency description? So gas blow by sulfonal flush drum system and potential overpressure, risk of loss of containment, fire, explosion, and H2S release, and release of sulfur into the ground. So this can be the impact. Now if we consider the severity level of this, so safety severity level is 6, because there is a chance of leakage of H2S that may lead to fatality. Environmental severity is 4, and financial severity level is also 6, right? So what is the initiating cause for this? So as we discussed in the HAZOP, the initiating cause may be the malfunction of the level controller leading to open of the control valve fully. So that we consider here initiating cause, okay? And this is actually the more flow situation, right? So somebody may ask that whether we need to do HAZOP or we can directly jump into LOPA. So to answer this question, it is always good to do HAZOP, because LOPA is more in-depth analysis, takes more time, and the initiating cause are more easily can be found if we do the HAZOP, right? Because HAZOP is mainly the process of hazard identification. So it will identify the hazard, and LOPA is basically technique of hazard reduction. So it is more focused towards reducing the hazard. So we do HAZOP for identifying the hazard and do LOPA to reduce the risk. Okay. So the initiating event likelihood is 0.1. As you can see, this is 0.1, and this where from we get this 0.1. We have various data sources like CCPS, EXIDA, SINTEF, etc. So which signifies that initially likelihood of this kind of event occurring may be 1 in 10 years, right? So that's why we have given is 0.1. Now what is the protection layer? So there is protection layer, but like alarm, but we have not considered it here because in many cases actually the alarms are not considered as a protection layer or taken as a credit, because of the fact that alarm actually on its own cannot do anything, right? It cannot automate any action. Ultimately the alarm needs to be seen by a operator, and he or she needs to take action accordingly. So it is better to not to take the credit of the alarm, but it is not a very hard and fast rule. Depending on the situation of your plant, you may choose to take the credit of alarm or not. So if you go with that, so there is other mitigation layer like PRB is present. So PRB, so in case of the overpressure, the PRB will pop up, and that will not allow the overpressure scenario and rupture of the flush drum. So we can take credit of that. So and the credit is e to the power minus 2. So if we combine these three, so this is our Fi, and this is our P1, P2, P3, P4. So ultimately this resultant demand frequency or overall PFD will be this RDF will be Fi into P1, P2, P3 into P4, and this comes out to 1 e to the power minus 3. So this portion is now done. Now next we will go to the next level. So this is the same thing, the initiating event frequency from where we can get it. So there are lots of sources like 𝐴𝒆𝒄𝒊𝒂𝒄𝒕, CCPS, SINPE, FEXIDA, ORIDA database. So from this database we can take it. Or if your plant is already maintaining the failure rates and you are quite sure that they are authentic, then you can take the same. Okay, so this is again the independent protection layer uh, credit. So this is also available from failure database. Now again, if we look into the complete flowchart of the LOPA, so this is one thing, and this resultant demand frequency we have achieved. Now we need to assess the severity of the consequence and determine target mitigated event likelihood. So this portion now we need to do, and for this, what we have, or what normally organization have, a risk matrix. So they have a risk matrix depending on the type of the risk, right? So the risk matrix can be categorized into 3 or more components also. Like a standard thing is to categorize it at least in 3 portions. One is health, another is environment, another is financial loss. Okay, and in that also we can have multiple severity level like 1 to 7. So 1 being a first rate injury and 7 is fatality more than 10 fatality. So this is just an example. This may or may not be followed by your organization, but your organization should have a risk matrix, and that risk matrix should be followed by all over, or all assets across your organization. So to get a standardization, right? So you can say that if there is a chance, like in this case, we have denoted that safety or health safety or and health severity is 6. So that means we have 2 into 10 to the power 2 to 10 fatalities, and this means that TMEL will be 1E minus 5. So if we have, and we have environment that is like this one, and we have financial one, this one. So overall, we can then say that our TMEL will be 1E minus 5, right? So we have now RDF, which is 1E minus 3. This is our RDF, and this is our TMEL. Okay, now we need to compare this result between these two, right? So if what we get now, this is our TMEL, and this is our overall PFD. Now as you can see that TMEL is less, so as TMEL is less, then we need to have a seal, and seal requirement will be obviously the TMEL by or RTF by TMEL. So this comes out to be 1E minus 2, which means the seal requirement is seal 2. So this is for the safety case. Similarly, in environment case, no seal is required. For the financial case, seal 2 is required. So overall seal requirement is seal 2. So this is what we achieve ultimately from the LOPA analysis. Okay, we calculate RDF, we calculate TMEL, we compare both of them, and then we determine what will be the requirement for the seal, and if the seal is really required, what will be the seal classification. So in this case, we have found that the seal requirement is seal 2. Okay, so that's it. Hope you have understood how to conduct the LOPA, and next time when you see any LOPA report, or when you will be conducting the LOPA on your own, so you will be much more confident. So if you have any query regarding the LOPA, please write in the comment. Thank you.